Implementation of hypersonic missile technology in 2024, 5 key phases and $4.2 billion defense budget allocation. Overview. In 2020 the U.S. military is set to make significant strides in hypersonic missile technology supported by a robust $4.2 billion allocation from the defense budget. This strategic investment reflects an urgent response to increasing global competition and emerging security threats, particularly from nations such as Russia and China that are also advancing their hypersonic capabilities. The implementation of this technology will unfold in 5 critical phases, each designed to build upon the previous one, ensuring a comprehensive approach to development, testing, and deployment. Key phases of implementation. 1. Research and development (R&D). The first phase focuses on the foundational aspects of hypersonic technology, emphasizing research and innovation. This includes extensive testing of materials that can withstand extreme temperatures and pressures, development of advanced propulsion systems for sustained hypersonic speeds, and enhancement of guidance mechanisms for precision targeting. The R&D phase is essential for establishing a reliable basis for hypersonic missiles, aiming to mitigate risks associated with untested technologies. 2. Prototyping and testing. Following the R&D phase, the initiative will transition into prototyping and rigorous testing of hypersonic missile designs. This phase aims to validate the functionality and performance of prototypes under various operational conditions. Testing will involve simulated environments that replicate real-world scenarios, allowing engineers and scientists to identify potential failures and areas for improvement before moving towards mass production. This stage is crucial for ensuring that the technology meets the operational expectations of the military. 3. Production and deployment planning. Once prototypes have been validated, the focus will shift to planning for large-scale production. This phase will involve strategic coordination with defense contractors to establish manufacturing capabilities, ensuring that production timelines align with military needs. The allocation of resources and infrastructure development will play a pivotal role in the successful transition from prototype to production. Additionally, this phase will address logistics and supply chain management to facilitate efficient deployment of the hypersonic systems. 4. Operational integration. The fourth phase is centered around the integration of hypersonic missiles into existing military frameworks. This process will require collaboration between various branches of the armed forces and other defense systems to ensure seamless operational capabilities. Command and control structures will be adapted to utilize hypersonic missile technology effectively, necessitating training for personnel on the new systems. This integration is vital for maximizing the operational potential of hypersonic missiles in conjunction with traditional weapon systems. 5. Full operational capability. The final phase aims for full operational capability, wherein hypersonic missiles are fully deployed and utilized in active service. This phase includes extensive training exercises for military personnel, live-fire tests, and the refinement of tactical doctrines to incorporate hypersonic capabilities. Achieving full operational readiness will also require ongoing assessments and adjustments based on real-world performance and advancements in technology. Strategic importance of hypersonic technology. The allocation of $4.2 billion for hypersonic missile technology underscores its strategic importance in modern warfare. As global threats evolve, maintaining a technological edge is crucial for national security. Hypersonic missiles capable of traveling at speeds exceeding Mach 5 present unique advantages in terms of speed, maneuverability, and reduced reaction times, making them difficult for adversaries to intercept. Global context and competition. The urgency for hypersonic advancements is heightened by the fact that the U.S. is not alone in pursuing this technology. Countries such as Russia and China are also investing heavily in hypersonic capabilities, showcasing their own advancements through successful tests and operational deployments. This competitive landscape necessitates a rapid and effective response from the U.S. military to ensure deterrence and maintain strategic superiority. Common key points across sources. A consensus exists among various sources regarding the 5 phases of implementation and the budget allocation for hypersonic technology. Key points highlighted include the strategic importance of hypersonic technology in the context of national defense, the structured approach to implementation through clearly defined phases, the necessity of addressing potential challenges in R&D testing, and operational integration. Differences between sources. While many sources align on the overall framework of the implementation plan, differences emerge in the emphasis placed on specific phases. Some reports stress the urgency of the R&D phase due to pressing geopolitical pressures, while others highlight operational integration as a particularly challenging aspect. Additionally, certain analyses provide insights into specific use cases for hypersonic missiles, such as targeting high-value assets, which may not be uniformly discussed in all sources. Timeline of events. 2023, initial discussions regarding funding for hypersonic missile technology begin, driven by increasing concerns over global advancements in this area. Early 2024, the formal announcement of the $4.2 billion budget allocation for hypersonic missile technology is made, marking a significant commitment from the U.S. government. Mid-2024, the R&D phase gains momentum with contracts awarded to various defense contractors, signaling the start of intensive research efforts. Late 2024, prototyping and testing phases commence, with anticipated trials to assess the capabilities and performance of hypersonic missiles. Conclusion. The 2024 implementation of hypersonic missile technology represents a pivotal moment for the U.S. military, with a well-structured 5-phase plan aimed at ensuring operational readiness against evolving threats. The strategic investment of $4.2 billion highlights the importance of maintaining a technological edge in the face of global competition. By focusing on both development and integration, the U.S. aims to leverage hypersonic capabilities to enhance national security and deter potential adversaries effectively. The implementation of hypersonic missile technology in 2024, backed by a substantial $4.2 billion defense budget allocation, reveals several counterintuitive aspects regarding military modernization and national security strategy. Here are some key points that highlight these counterintuitive elements. 1. Perception of urgency versus reality of development. While the allocation of the budget and the structured 5-phase implementation plan signal a pressing need for hypersonic capabilities, the actual technology development cycle is lengthy and complex. Despite the immediate geopolitical pressures from adversaries like Russia and China, actual deployment may lag behind expectations, potentially leading to a misalignment between perceived urgency and real-world readiness. 2. High budget allocation versus limited immediate impact. A $4.2 billion budget may seem substantial, but when examined in the context of the overall defense budget, which runs into hundreds of billions, this allocation for hypersonic technology represents a fraction of total spending. This raises questions about the effectiveness of such a focused investment and whether it can deliver the transformative impact anticipated in military capabilities, especially when compared to other ongoing defense programs. 3. Focus on R&D versus operational integration challenges. The emphasis on research and development as the initial phase may mislead stakeholders into thinking that the technological hurdles are the primary barriers. In reality, the operational integration of hypersonic missiles into existing military frameworks could present even greater challenges. The complexities of command and control interoperability with existing systems and the training of personnel may ultimately prove more significant than the technological advancements themselves. For geopolitical competition versus collaborative potential, the narrative often emphasizes competition among nations in hypersonic technology, suggesting a zero-sum game where advancements by one country directly threaten another. However, there is a counterintuitive potential for collaborative efforts in defense technology. where shared advancements could lead to mutual benefits and reduce the risk of conflict. The singular focus on competition may overlook opportunities for joint developments that could enhance global security. 5. Public perception of military readiness versus actual capabilities. The public and political narrative around hypersonic missile technology often emphasizes the need for immediate readiness in response to perceived threats. However, the actual capabilities of hypersonic missiles, including their effectiveness and reliability, remain under scrutiny. There is a risk that public perception might not align with the operational realities, potentially leading to misguided policy decisions based on overstated capabilities. In conclusion, the implementation of hypersonic missile technology in 2024, while strategically important, is fraught with complexities that challenge conventional assumptions about military modernization funding and national security. The interplay of urgency, budget constraints, technological challenges, and geopolitical dynamics presents a multifaceted picture that goes beyond simplistic narratives of competition and readiness. The report on the implementation of hypersonic missile technology in 2024, with a substantial $4.2 billion defense budget allocation, outlines a strategic framework divided into 5 key phases. While many aspects of the report may seem straightforward, several crucial details are often overlooked which have significant implications for the future of U.S. defense capabilities. 1. Research and development phase, the underpinning of future success. The R&D phase is not merely a preliminary step, it is the foundation upon which the entire hypersonic missile program rests. Many may underestimate the complexity and time required to advance scientific understanding in materials, propulsion systems, and guidance mechanisms. The significance lies in the fact that this phase addresses potential vulnerabilities in hypersonic technology. If the materials developed during R&D do not withstand the extreme conditions of hypersonic flight, or if the propulsion systems fail to deliver the expected speeds and maneuverability, the entire program could falter. Furthermore, the focus on materials science, such as developing heat-resistant alloys or advanced composites, may not receive the attention it deserves. The unique operational environment of hypersonic missiles requires innovations that go beyond current aerospace technologies. Ignoring the importance of this phase could lead to a lack of readiness in subsequent phases, jeopardizing the overall timeline and effectiveness of the program. 2. Prototyping and testing, the crucible of validation. Prototyping and testing are often seen as straightforward steps, yet they are where theoretical designs meet the harsh reality of operational conditions. This phase is significant because it serves as a critical checkpoint to validate designs and functionality. The overlooked aspect is the potential for failure during testing, which could lead to delays and increased costs. Moreover, the report points to rigorous testing under various conditions, but the implications of not fully understanding the interplay between different environmental factors like atmospheric pressure, temperature variations, and aerodynamic forces at hypersonic speeds are profound. A failure in this phase could result in a loss of confidence from stakeholders and possibly deter future investments in hypersonic technologies, affecting the U.S.'s competitive edge against adversaries like China and Russia. 3. Production and deployment planning, a logistical challenge. The production and deployment planning phase might seem like a logistical detail, but its significance cannot be overstated. Coordination with defense contractors is not simply about manufacturing, it involves establishing a supply chain that can adapt to the rapid advancements in technology in changing geopolitical landscapes. An often overlooked element is the necessity for a flexible manufacturing process that can quickly scale up or pivot based on testing outcomes or strategic needs. For instance, if testing reveals the need for redesigns or enhancements, the production process must be agile enough to accommodate these changes without significant delays. The ability to respond to these challenges will determine the U.S. military's readiness and responsiveness in a fast-evolving threat landscape. 4. Operational integration, the complexity of systems integration. Operational integration is a phase that demands significant attention. as the successful deployment of hypersonic missiles relies heavily on how well these systems are integrated with existing military frameworks. The significance of this phase lies in the challenges associated with command and control structures which must evolve to effectively utilize hypersonic capabilities. Many reports gloss over the technological hurdles and training requirements needed for personnel to operate these advanced systems. The potential for operational failure due to inadequate training or lack of understanding of the new systems could undermine the advantages offered by hypersonic technology. Additionally, the integration of hypersonic missiles with current defense systems like missile defense and surveillance systems poses intricate technical challenges that must be carefully managed to ensure operational success. 5. Full operational capability, beyond deployment. Achieving full operational capability is not merely about deploying hypersonic missiles, it encompasses the broader implications for U.S. defense strategy and posture. The report highlights the need for training personnel and conducting live exercises, yet it fails to emphasize how the introduction of hypersonic weapons alters the strategic calculus of the U.S. military. The training of personnel is not just about operational effectiveness, it also involves understanding the ethical and strategic implications of deploying hypersonic missiles. The ability to engage in rapid strikes against high-value targets changes the rules of engagement and requires a re-evaluation of military doctrine. The potential for miscalculation in high-stakes scenarios could lead to escalatory responses from adversaries. A nuance that is critical yet frequently overlooked in discussions about hypersonic capabilities. Conclusion: the strategic imperative of hypersonic technology. In summary, the implementation of hypersonic missile technology in 2024 is a complex endeavor that extends far beyond the allocation of a $4.2 billion budget. The 5 key phases outlined in the report are interlinked and each carries significant implications for the program's success. The importance of R&D, rigorous testing, agile production, operational integration, and the implications of achieving full operational capability are critical to understanding the strategic landscape of modern warfare. Overlooking the nuances and challenges associated with these phases could result in underestimating the complexities of integrating hypersonic technology into U.S. military operations. As global competition intensifies, the U.S. must not only advance its hypersonic capabilities but also ensure that these systems are effectively integrated into a broader defense strategy that accounts for the evolving nature of warfare and international relations. 1. Strategic importance of hypersonic technology. The $4.2 billion allocation for hypersonic missile technology reflects the U.S. military's recognition of the growing strategic importance of this capability in modern warfare. As global competition intensifies, particularly with nations like Russia and China advancing their hypersonic programs, this funding is crucial for maintaining a technological edge. The urgency of developing hypersonic systems is underscored by the potential for these weapons to evade traditional missile defense systems, making them a formidable component of a nation's defense strategy. 2. Structured 5-phase implementation plan. The implementation of hypersonic missile technology is organized into 5 distinct phases: research and development, R&D, prototyping and testing, production and deployment planning. Operational integration and achieving full operational capability. This structured approach ensures that each aspect of development is thoroughly addressed. The R&D phase is particularly crucial as it lays the groundwork for technological advancements, while the testing phase is vital for validating the functionality and reliability of prototypes before moving to mass production. Each phase builds upon the previous one, emphasizing a comprehensive strategy for effective deployment. 3. Challenges in operational integration. One of the most significant challenges highlighted is the operational integration of hypersonic missiles into existing military frameworks. This requires not only technological adaptations but also the development of new tactical doctrines and training programs for military personnel. Effective command and control structures must be established to leverage the capabilities of hypersonic systems fully. The complexity of integrating these advanced weapons into traditional military operations poses a critical challenge that could impact the overall effectiveness of the hypersonic program. 4. Global context and competitive landscape. The U.S. is not operating in isolation regarding hypersonic technology. Other nations, particularly Russia and China, are also making significant advancements. This competitive landscape heightens the urgency for the U.S. to accelerate its hypersonic programs to counter potential threats. The reality of a multipolar world where various nations possess hypersonic capabilities necessitates a proactive approach in both development and deployment strategies to ensure national security. The analysis of global advancements in hypersonic technology is essential for understanding the strategic imperatives driving U.S. defense spending and policy decisions. These 4 points encapsulate the critical aspects of the implementation of hypersonic missile technology, focusing on strategic significance, structured development phases, operational challenges, and the competitive global environment. 1. The Manhattan Project 1942 to 1946. This was a research and development project during World War II in the United States that produced the first nuclear weapons. The project involved significant funding and collaboration among various scientific and military entities. It progressed through key phases including initial research, development of prototypes, the atomic bombs, testing, the Trinity test, and eventual deployment Hiroshima and Nagasaki. The urgency of the project was driven by the need to develop an effective weapon before Nazi Germany could achieve the same goal, illustrating the geopolitical pressures similar to those faced with hypersonic missile development today. 2. The Apollo Program 1961 to 1972. Initiated by NASA, the Apollo program aimed to land humans on the Moon and bring them safely back to Earth. The program included phases of research and development, prototyping with multiple Apollo missions leading up to the moon landing, rigorous testing including unmanned missions, and operational integration into U.S. space exploration efforts. The Apollo program required substantial budget allocations and represented a significant technological competition in the context of the Cold War, paralleling the current race for hypersonic capabilities among global powers. 3. Development of the F-35 Lightning II 2001 present. The F-35 program is a joint strike fighter initiative led by the United States with contributions from several allied nations. The program has gone through various phases including extensive research and development, prototyping with multiple variants of the aircraft, operational testing, and ongoing production planning. The integration of advanced technologies including stealth and sensors reflects the challenges and complexities similar to those of hypersonic missile technology. The F-35's development was also marked by significant budgetary allocations and international collaboration akin to the current defense budget discussions surrounding hypersonic missiles. Future outlook: predictions for hypersonic missile technology implementation by 2025. As we move towards 2025, the implementation of hypersonic missile technology, driven by a significant $4.2 billion defense budget allocation in 2024, is poised to reshape the landscape of modern warfare. Here are key predictions for the future of this technology. 1. Accelerated technological advancements. By 2025, we can expect to witness accelerated advancements in hypersonic technology. The first phase, focusing on research and development (R&D), will yield breakthroughs in propulsion systems, materials science, and guidance technologies. The urgency of geopolitical dynamics, particularly with nations like China and Russia advancing their hypersonic capabilities, will fuel innovation. Collaborative efforts between government and private sector entities will likely result in significant enhancements in speed, maneuverability, and reliability of hypersonic missiles, setting new standards in military technology. 2. Successful prototype testing and validation. Following the R&D phase, the prototyping and testing phase will produce successful trials by mid-2025. Expect multiple prototypes to be tested under various operational conditions, leading to critical assessments of their performance. This phase will not only validate design concepts but also refine them based on real-world data. The anticipated success of these tests will pave the way for confidence in hypersonic missile deployment and will likely lead to a faster transition to mass production. 3. Strategic deployment and operational integration. As the production and deployment planning phase unfolds, we can predict a robust strategy for operational integration by late 2025. Hypersonic missiles will be integrated into existing military frameworks, enhancing the U.S. military's overall strategic capabilities. This integration will involve sophisticated command and control systems capable of managing hypersonic assets alongside traditional weaponry. Training programs for military personnel will also be developed to ensure effective utilization in various combat scenarios. 4. Heightened global arms race. The advancements in hypersonic missile technology will contribute to an intensified global arms race. By 2025, we can expect not only the US but also other nations to enhance their military capabilities, leading to a more complex geopolitical environment. Countries such as China and Russia, already investing heavily in hypersonic systems, will likely accelerate their programs in response to US advancements. This arms race will necessitate robust diplomatic efforts to manage tensions and prevent escalation. 5. Tactical evolution in military operations. With the full operational capability of hypersonic missiles achieved by 2025, military operations will undergo a tectonic shift. The ability to strike targets at unprecedented speeds will redefine tactical doctrines with a focus on preemptive strikes against high-value assets. Commanders will leverage hypersonic capabilities for both deterrence and rapid response, fundamentally altering strategies in regional conflicts. Additionally, joint exercises involving hypersonic systems will become common, further embedding this technology into military culture. Conclusion. The implementation of hypersonic missile technology, underpinned by a $4.2 billion defense budget, is set to be a game-changer by 2025. With phases of R&D, prototyping, production and operational integration progressing as planned, the U.S. military is on the verge of a technological revolution. However, this also heralds an era of heightened global competition, requiring strategic foresight and diplomatic engagement to navigate the complexities of a rapidly evolving defense landscape. As we approach 2025, the implications of hypersonic technology will extend beyond military capabilities, influencing global security dynamics and international relations for years to come.